Hello, today we are going to talk about scale drawings and scale models, and this is section 6.6. Please make sure you have your handout ready and your notes paper. So you've seen scale drawings and models before. Think maps, blueprints, model cars, model airplanes, a model of a heart. In science, I'm sure you've seen other models that represent different plant cells, things like that. Basically, these items are used to represent objects that are too small or too large to be drawn or built at their actual size. The lengths and widths of these objects on a scale drawing or model are proportional to the lengths and widths of the actual objects. So let's go ahead and get that down. So basically they're used to represent objects that are too small or too large to be drawn or built at their actual size. And the lengths and widths are proportional. So I'm just going to write everything is proportional. That's the key point here. If we didn't have proportional objects, we wouldn't be able to actually say what the actual size of an object might be. If I was an architect and I was drawing out the plans for your new kitchen, this would not be acceptable. Here's some cabinets here and some cabinets here, and then here's a fridge. Okay, you'd need to know exactly, well, what does this measurement mean? What is 1 centimeter equal to in real life? And order everything appropriately. So measurement definitely matters, and being proportional definitely matters. We talk a lot about scale. The scale is the ratio of a given length on the drawing or model to its corresponding length on the actual object. So think of a map. They might tell you that every inch represents 100 miles, or 1 inch represents 20 miles. It depends on how zoomed up we're looking at. Maybe you just have a map of Baltimore, but maybe you're looking at a map of the world. Obviously the scale would be very different on those two maps. So again, it is the ratio of a given length on the drawing or model to its corresponding length on the actual object. So for example, I can say 1 inch represents, like I said, 20 miles. Knowing the scale is really helpful because you can use it to set up a proportion to find what the values might be either on the map or in real life. So definitely we will be using these to solve different types of problems. Just a few notes about scale. This is the nitty-gritty. They are written so that a unit length on the drawing or model is listed first. So what does that mean? Well, you will always see the scale written with the model length. So in this case I wrote 1 inch. That would be the model or the map. To the actual length. The actual length in this case being 20 miles. It's okay to have different units. Here I have an inch compared to miles. That's fine when we're talking scale. But something really important, there must be a 1 in the numerator. If I was to write this as a fraction, it would be 1 inch over 20 miles. So must have 1 in the numerator. And that's what I was talking about before, the unit length. I want to know what 1 inch on my map represents. It's not super helpful if I know what 2.5 inches happen to be. So it's 1 inch for every 20 miles. That's a lot easier to work with. Think about any models you've ever created. Also, if you've ever put together a little model car, you know, what's 1 centimeter worth? What's 1 millimeter? Well, that'd be really tiny. 1 inch, 1 foot. Okay, so always have a 1 in the numerator. And just something else to say, it's okay to have a decimal in the denominator. Don't be worried about that. If you start calculating and you realize you have a decimal in the denominator, that's okay. So let's go ahead and take a look to see how we can use scale. Please get out page 35. And let's just take a look at number 1. So here we're talking maps. So Joanna knows the distance to her grandmother's house is 21 miles. And on a map, the distance is 5.25 inches. What's the scale of the map? So again, we always want to put the model to the actual length. So I'm not going to put 21 miles over 5.25 inches, even though 21 is listed first in this problem. What I'm going to do is look at the model, and in this case we're talking the map. So that's 5.25 inches to the actual distance of 21 miles. And we want to know the scale. Well, we almost have the scale. I have different units, that is fine. I have my model to the actual. What do I need to do? I need to get a 1 in the numerator. So let's go ahead and set up a proportion to solve for that. So basically I want to have 1 over some number. By setting up this proportion, I can solve it using the cross product. Then I can divide both sides by 5.25. This is where you may use your calculator for this calculation. And what do we get? We get 4. So with the scale, let's go ahead and list the units. So we know that for every 1 inch on the map, we have 4 miles. Okay, so that is the scale. Let's take a look at number 2. So Kevin drew a scale drawing of his living room. The actual room is 16 feet long. If the room is 12 inches long in the drawing, what is the scale of the drawing? So again, we want to focus on the 12 inches first. 12 inches represents 16 feet. And again, we would like to have a 1 in the numerator. So let's set up the proportion. Go ahead and solve using the cross product. And here we'll get a decimal. And it goes on forever, 1.3 repeating. Let's go ahead and round to the nearest tenth. So we'll say that x equals 1.3. Now when we set this up, we can say that for every inch on Kevin's drawing, we have 1.3 feet. Okay, so that would be the scale. Please do number 3 on your own and hit play when you're ready to see the solution. Okay, so with number 3, 1 inch to 3 feet is the solution. And to get that, you could start off with 15 over 45 equals 1 over x. Again, use the cross product, and this works out really nicely. So 1 inch to 3 feet. You can use scale to find missing lengths. Here we were just finding the scale. So let's take a look at page 37. You'll see that we have a table there. It says on a set of architectural drawings for a new school building, the scale is 1/4 of an inch to 2 feet. Now here they did not give us the scale as a unit of 1 in the numerator. We could go ahead and change it, but at this point in time, it is fine if we use this as is. Let's find the missing lengths of the room because that's what we're directed to do. So we can use this ratio. Let's see, number 1 with the lobby, they give us an actual length of 16 feet. So here, what we can do is use the scale that we were given, 1/4 of an inch to 2 feet, and we can set it equal to x over 16 feet. You don't have to worry about converting any of our numbers here because whatever we find is going to be in inches. Again, we can cross multiply. This works out really nicely. Divide by 2 and you will get x equals 2. So in this drawing we will have 2 inches representing the length of the 16-foot lobby, 16-foot long lobby. We can look at number 2 and do the same thing, the principal's office. So again, using the scale that we were given, we can set this up, and in this case we were told that in the drawing it's 1.25 inches. We do not know the actual length. So let's solve this proportion. When we calculate this out, we get 1/4 x equals 2.5. Divide by 1/4, and remember 1/4 is just 0.25, and we do in fact get a nice number of 10 inches. Hit pause and please complete the rest. Okay, so let me just go ahead and read off the answers. Number 3 is 2.5 inches. Number 4 is 24 feet. Number 5 is 12 feet. Number 6 is 6 inches. Number 7 is 32 feet. Number 8 is 104 feet. Number 9 is 7 inches. And number 10 is 14 feet. I just noticed that I wrote 10 inches before when I needed to write feet. So please make sure that for number 2 you actually wrote 10 feet and not 10 inches. If you take a look at number 11, it says referred to exercises 1 through 10, what is the scale factor? Well, we haven't talked about that just yet. It turns out that the scale factor, let's make a note. The scale factor is basically the scale with the same units in the numerator and denominator. When you have the same units, you can tell how many times larger or smaller the model or drawing actually is if we have a numerator of 1. So again, it's the scale with the same units in the numerator and denominator. So let's take a look at number 11 and let's figure out the scale factor. So the scale we were given was 1/4 inch to 2 feet. So let's go ahead and convert this so that we have the same units. Well, it looks like we can definitely convert 2 feet into inches, so we multiply by 12, we get 24 inches. And let's go ahead and make it a numerator of 1, just so that it is easier to see what's actually going on here. In order to make this 1/4 into 1, I can multiply by 4. When I do that, I can now see that 1 inch is 296 inches. Okay. So we can say that 196 is the scale factor of the given scale 1/4 inch to 2 feet. And basically, this drawing is a 96th the size, 1/96th the size of the actual school building. That's the idea here. So we can say that for every unit in the drawing, we are representing 96 units in real life. Now, before we were using the scale to find missing drawing lengths and missing actual lengths, but you could also use the scale factor. I'm not going to show you how to do that here, but it is in your textbook, and you may take the scale factor and set up an equation of the form y equals kx, in order to solve these same types of problems. I'm going to stick with the scale and proportions. What I'd like you to do now is to go ahead and do number 12, please, and hit play when you're ready to see the solution. Okay, so here, what is the scale factor if the scale is 10 inches to 1 foot? Let's go ahead and convert so that we have the same unit in top and bottom, on top and bottom. And then here, I'm just going to keep it 5 to 6, 5 inches to 6 inches. You do not need to change it so that the numerator is 1. I'll see you in class. Thanks.